In this video, I'm going to continue talking about ionic compound nomenclature or naming, and add in a few more kind of exceptions to our base set of rules. So first, I want to talk about how our polyatomic ions get their names. And there's a series of kind of detailed naming I guess, rules that lead up to some of their actual names that I will not go into a ton of detail. I would like to highlight, though, oxyanions. We'll work with oxyanions and then later oxyacids quite a bit, and the naming conventions are similar. And so it's worth, I think, spending some time on. A lot of our polyatomic ions are oxyanions, and that just means that they contain an oxygen atom. So if there are more than one type of ion that has oxygen and another element, and so let's say nitrogen, right? So if there's more than one nitrogen-oxygen combination, then we will always give the one that has more oxygen atoms of the two an ATE ending on its name, like this. So instead of nitrogen, it becomes nitrate. And then whichever one has fewer oxygen atoms would get the ITE ending, nitrite. And so my NO3 with more oxygens has the ATE ending, and the NO2 has even has fewer oxygens, so it has the ITE ending. So the problem with navigating this is it requires you to know what are the possible combinations that nitrogen and oxygen would form to make an anionic polyatomic ion. And so I feel like that is a little bit outside the scope of intuition that I expect for a first quarter Gen Chem student. So there's that. Um, Now, if there's even more ions that form between an element and oxygen, then we have a second kind of layer of terminology we add to this. So chlorine will form a compound with uh, oxygen that's one chlorine and one oxygen. And then it'll form one with two, and then with three oxygen and with four oxygen. And so we go into this center here, and the one with the two oxygen versus three oxygen, and these are just the middle two of the four possibilities. So we could be looking at 3 and 4 oxygen, but we have the smaller one be chlorite and the larger one be chlorate, similar to what we did with nitrogen. But then the smallest becomes hypochlorite, and so we're adding this HYPO at the beginning of the polyatomic ion name. And the largest one with 4 oxygen gets perchlorate. And so again, you need to know all of the possible ions that would form with oxygen for that element. And then you can go through and determine what the names would be. It's not always associated with an exact number of oxygens. So something with 2 oxygens is not always element ite ending, so like chlorite or nitrite. It depends on what is possible. Again, that takes a lot of experience getting to know these molecules, and right now I expect you just to look these up. Another naming convention kind of steps outside the actual ionic compound itself. When these ionic compounds form as salts, they often form salt crystals. And when they form those crystals, they sometimes crystallize with water around them. And so you have some water molecules that are in a solid with your ionic compound and interspersed throughout it. It's the way that the solid forms. And so the water is not bonded and to the ionic compound, and so it's not actually part of the ionic compound. But when you're weighing it out, the way the crystal forms will create a consistent and reproducible number of waters that are trapped within the solid structure. And so to weigh it out and to manipulate it, we need to know what we're actually weighing. We need to account for that water. Otherwise, we would be weighing the wrong amount of our crystal or our ionic compound solid. And so we track those waters that we know will consistently form along with that solid as a hydrate. And so when we know a consistent number of water molecules associated with a crystal form alongside it in the solid state, we show that hydrate, or that we name it with a dot in the middle of the line, followed by the number of waters. So in this case, we're looking at magnesium sulfate heptahydrate. And that's how we're going to name it afterwards. So we name that magnesium sulfate. We have our cation and our anion. We have a polyatomic anion. And so in our name, we have written out our cation's just elemental name. And then we found the name of our polyatomic ion from our polyatomic ion chart, sulfate. And then we follow it with a space and then as one word, the hydrate. And so we're going to say the number of water molecules is 7, and we use prefixes to say that number before the word hydrate. And here are the common hydrate prefixes. If you have half of a water crystallizing, and you don't actually have half of a molecule, it means you have 1 molecule for every 2 units of your ionic compound. But you'll always have your ionic compound in its most reduced form, and so that might mean half a water. We would call this hemihydrate. If it's 1, it's monohydrate. If it's 2, it's dihydrate. 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa. And so these you should get very familiar with, and this kind of naming convention will be used for numbers throughout chemistry.